Okay. So chapter 1 in your, make sure that I'm actually recording. Okay, so chapter 1 in the textbook, in this heat pumps textbook, is going to cover basic principles of operation of refrigeration. So that should be a review, hopefully. Not going to spend a ton of time on that, but we're going to use that to then work into how a heat pump works. So we hopefully at this point know the basic refrigeration cycle. Here's actually a better view of it than what we've had in the past. I actually just got this breakdown. So starting entering the compressor, we know the state of refrigerant is a low pressure, low temperature, superheated vapor. It has to be vapor, 100% vapor, in order to prevent damage to the compressor, and also, well, a few things. It has to be vapor so it can be compressed, but then it also limits damage to the compressor by limiting the amount of oil that would be lost due to oil migration due to liquid in the crankcase. So a few reasons why you don't want that liquid into the compressor, and that's still going to apply in heating. So nothing changes there. Basically, the same circuit is going to be in play in a heat pump as it is in an air conditioner. Just the location and some of the specifics are going to be a little bit different. And so in your traditional AC, you've got a condenser coil, which is outside, and in that condenser coil, the compressor compresses that low pressure vapor to a high pressure hot gas, high temperature, and it is superheated. And the first thing that has to happen is it has to become de-superheated. Then it starts to condense, and then it leaves 100% liquid before it gets to the metering device. The metering device can only handle liquid, or it's supposed to, it only handles liquid well. And so that liquid refrigerant goes through that metering device, and this is where your low side starts again. So you'll notice this is split, high and low, or blue and red. So the metering device is going to break that down, reduce the pressure, split it from 100% liquid to a 75%, 25% liquid vapor mix, and go through the evaporator where it picks up heat from inside or whatever we're trying to condition. And as a result, that vapor picks up, or that refrigerant picks up the heat, which makes it become a vapor. Still low pressure, low temp, and it becomes superheated before it enters the compressor again. So, that's your basic circuit. Hopefully, we kind of understand that at this point. And then, as a result, we bring in, let's say, 70-degree air, if it's 75-degree air, if it's an air conditioner, and we reduce the temperature of that about 20 degrees, give or take. That's called delta. So if we got 75 in and 55 out, we've got a 20-degree delta. The temperature difference of the refrigerant, the saturated temperature difference, is called TD, temperature difference, and that should be about 30 to 35 below your indoor temp, and your condenser temp should be roughly 15 to 30 degrees above, depending on efficiency, above your outdoor unit, or above your outdoor temperature. So that's your AC circuit. Now, let's get into this. Now, here's the cool thing about heat pumps. There are different types, and depending on where you work, what location, what geographical location it's going to depend on, that's going to change a lot of what you see. So if you're doing commercial, if you're doing residential, if you're doing geothermal, or if you're mainly doing air-to-air, if you're working with working more south, you're going to see more heat pumps. If you go farther north, you're going to see less heat pumps. Now, because they are getting more efficient, you're probably going to start seeing more heat pumps, even in those areas that normally you wouldn't. But the thing about a heat pump is they essentially flip the circuit. So you move heat from one place to another. Air conditioning is usually cooling a place down, keeping it cold. In this case, they're taking that same principle and they're just flipping the direction of the refrigerant, and they're making the indoor unit your condenser, your outdoor unit your evaporator. So The outdoor unit absorbs heat from outside. The indoor unit rejects heat inside. It's the same property, it's just backwards. So the terms indoor unit and outdoor unit may come into play more than condensing unit and evaporator. All right, so we'll pull this. Okay. So we know that hot goes to cold, and we know that in order for something to absorb heat, it has to be colder than what's around it or what it's absorbing heat from. And we know that in order to reject heat, we have to make that warmer than the air around it or the material around it. So same properties, same thing has to happen. We have to make the outdoor unit colder than outside. No matter how cold it is outside, it has to be colder. We have to make the indoor unit warmer than inside. No matter what it is inside, it's got to be warmer in order to reject, right? So we're still using the condensing and evaporating processes to do that, most of that work. Now, here's the cool thing about a heat pump. Heat pumps can do all, basically take care of a house year round. Whereas if you only have a gas furnace, or if you only have an air conditioner, or you only have, a wood boiler or whatever, that's specific. But a heat pump has the ability to do it both directions. So it has cooling capabilities, heating capabilities, all in the same unit. When we go to heating, we have to account in for defrost because, as we'll learn later, if we're going to absorb heat from outside, then that coil has to be below freezing or had to be below outdoor temps. It's obvious it's going to be running below freezing, and it's still going to attract moisture, especially if it's raining or snowing or moist outside. And we have to account for defrost. So we have to have a way to defrost. Main components are still basically the same. It's just the location. So you have an indoor coil, an outdoor coil, and a compressor. So you have a condenser, a evaporator, metering device, compressor, all four of those still in play. Your metering device, one thing that's different about a heat pump is you have two metering devices. You still have your indoor one that's used for cooling. Then you have an outdoor metering device, which is used for heating. So it goes right before the evaporator outside when it's in the other direction. And then one of the biggest differences, the way to tell, is you have a four-way reversing valve, or what people are just going to call a reversing valve. Your compressor is still doing the same thing. Really, it doesn't change at all. It just gets refrigerant from a different place. So the compressor doesn't, a lot of people maybe mistakenly think that in a heat pump, the compressor goes the other direction, that it goes backwards. That's not the case. The compressor is still turning in the right direction, the same direction that it was. It's not reversing. It's not doing something different. It's just the reversing valve is controlling where that refrigerant comes from and where that refrigerant goes. And then the compressor just gets suction gas from the evaporator and sends hot gas to the condenser. The reversing valve just determines where the location of those are. Same types of compressors we've talked about before: recips, rotary, scroll, different speeds and such. And this is getting into chapter 2 as well. So I'm not going to spend a ton of time on chapter 1. I'm just going to kind of zoom through the first couple of chapters on this. And like I said, this slide really isn't broke down by chapters. So we'll just go a little way and then we'll stop. All right, so in chapter 2, this looks to be on page 24, around page 24, where it's talking about the compressor. So this is getting more into your electronic side. We're not going to get into that right now as much, but the internal breakdown, electronic breakdown of these compressors. If you had ACR 102 and ACR 130, we've already kind of talked about this, so this should be fairly familiar. Your windings and such, your two-speed, multi-speed compressors, get into those later. Like I said, I'm just sort of zooming through this. We'll learn about variable speed a little bit. There's a good shot of a compressor, the pistons inside of a compressor, recip. So PowerPoint stop. All right, another difference, and my PowerPoint is, there we go. Okay, so indoor refrigerant coil. So if you have an indoor coil, it's not going to be a lot different, but you're going to have to make sure that coil will apply to the refrigerant you're using and that it's made for a heat pump. So if you have a straight AC coil, I'm not saying that it won't work, but I would always check with the manufacturer because those coils have to be designed to carry the load of the heat pump. So when we switch the direction of that circuit, you're going to send all that high pressure, all that hot gas into that evaporator. So now if you can imagine, you've got an outdoor unit that's pulling in free air in the summer. That's your condenser, right? So let me pull up another picture here. Maybe a better view here. All right, so here's your AC unit. So your AC system in the summer is what we've already talked about. You've got, this is just a typical AC system. You've got your suction gas coming in, then this compressor is a scroll, so that compressor is pushing that refrigerant out, hot gas to the outdoor coil. So imagine all this surface area around the surface of this coil, free air, there's no air handler, there's no filter to go through, it just gets it pretty easy, right? And there's a lot of surface area there. Now, look inside. If you've got in this case, your coil right here on the bottom, and then your ductwork on top, ductwork on the bottom, so you're more restricted. You've got a smaller blower, you've got a different type of fan, it's a blower instead of a fan. Your coil is an A coil style most usually, and the surface area on that is not nearly what you have outside. So it's not that crazy to think that your pressures and your temps are going to be a little hotter and a little higher inside on your heating mode when you switch that, just because of surface area and air restrictions and stuff. So some of our rules of thumb are going to change a little bit when we go into the heating mode. All right, so now let me pull up this other one. All right, so in the heating mode, you can see in this picture, hopefully you can see this well. It's actually a really good shot. So you've got your reversing valve here, your four-way valve. You'll notice they'll always have one pipe on the top, 3 pipes on the bottom. And 2 of those are going to be suction and 2 are going to be hot gas. And I'll teach you a little later on how to check those and stuff for failure. All right, so we've still got our same basic circuit, but now we've got some other stuff in play. We've got an accumulator, and if you look at that accumulator, the way that it kind of works, pretty cool little breakdown actually. So you got your suction gas coming in from your evaporator, which is now outside, going into the reversing valve. Now it's not always on the left. This is just happens to be turned that way, but your center port is always suction. So one of the outside ports will be suction, one of the outside ports will be discharge, depending on position and how it's turned and everything. It may be left or right, but the center will always be suction, and the one at the top by itself will always be hot gas. So those are your common ports. Your ones on the center always stay the same. The ones on the outside switch. So the suction gas comes into that accumulator, dumps it in. If there's any liquid that happens to make it past, that liquid will settle in the bottom until it boils off, and then the accumulator pulls out refrigerant off the top, vapor, so that no liquid can make it to your compressor, essentially, unless your accumulator gets full. So that's sort of a protection for that compressor, and it's also an additional storage place for some of that refrigerant if you have a little extra in the winter. So it's bringing in hot gas or suction gas, discharging out hot gas. Then the hot gas goes through the common discharge, the discharge line, and out, in this case, the right-hand side. So at this point, now you've got 2 pipes outside that are both high pressure. So in our cooling mode, we had, you know, low pressure on the big line, like we did in cooling, and high pressure on the liquid line, which is a small line. Well, the liquid line is always small. The difference is the direction that it's flowing. So in the summertime, that liquid is leaving this outdoor unit on that liquid line, and it's flowing into the metering device inside, going through the evaporator, and then coming back as suction gas. In heating mode, it's actually going the opposite way. So it's still liquid, but it's going the other direction. And here's why. Because as that vapor comes, that hot gas comes through that big line. So that big line is going to get hot now. If you have your gauges on that big line, that's going to be an issue. So you have to have another port to actually check your pressures, which we'll talk about later. So your big line is actually bringing discharge hot gas to the condenser. The condenser is now located where? Inside, right? So your condenser is going to condense refrigerant just like it always did. It's just in a different location. Hot gas goes through that condenser, and then it starts to condense. As it goes through the coil, it becomes 100% liquid, and that liquid goes right through that TXV backwards, right? There's a bypass that allows that to go through, so it shouldn't restrict at all. There shouldn't be any metering that takes place there. That's just out of the way now at this point. And then liquid through the filter dryer, outside, through the liquid line, into the outdoor unit. And then it finds its metering device. Now that metering device can be a piston, that metering device can be a TXV. You'll see both. So in this case, they've got it as a piston, and that metering device meters at this point before it gets to the evaporator coil. Now in this case, your evaporator coil is your outdoor unit, your outdoor coil. So what we used to call the condenser is now the evaporator. That refrigerant is going to do the same thing it did in cooling, and it's going to break down the liquid vapor mix and change to 100% vapor by picking up heat from outside. Even if it's cold, right? There's still heat available. So, down to, the teens or something, these compressors these systems are capable of doing pretty well now. Older systems struggle at cold temps. Anything below freezing, it's going to start to struggle. You're going to start to lose capacity in any of them, but this new stuff is getting pretty efficient in converting all that to heat. So suction gas coming in through your reversing valve into your accumulator and back to the compressor. So the heat that was picked up outside gets compressed, sent through the hot gas inside, gets rejected through condensing, comes back, starts it all over again. So this is your same process, it's just different, right? So let me let's back up. Metering device is still the same possibility. The four-way reversing valve. So this is actually a pretty good shot too. I do like that other one better though. So your center, and like I said, it could be upside down, it could be the other way. Usually it seems like that single port is on the top, but it could be either way. You got two ports that are hot gas, and then your center and your outside are cooling, and then when it switches, it's just going to go into the opposite position. Now, what makes it switch? We'll get into that a little deeper later on, but there's basically another little reversing valve on the solenoid, and when there's a solenoid, electrical solenoid, that energizes on the orange wire or blue wire in the case of Rude and Ream, that changes that direction. So the stat calls for whatever mode it's in, and that reversing valve actually switches spots. And so you'll notice in this, my mouse isn't cooperating, in this little picture, that reversing valve solenoid has moved, and as a result, that valve switches positions. So we'll get into that later a little better. My mouse is freaking out somehow. So I'm going to stop right there with that, and then close this out. But we're going to talk about this more, and we'll do this in class as well, and I'll draw it out and make sure that you understand it. But basically, the main thing to understand is that it's the same circuit, just backwards, just in reverse. Your indoor coil condenser, outdoor coil evaporator. You've got a reversing valve. So if I were to ask you what a heat pump is doing, or I mean, if a system is a heat pump, the first thing you're going to look for is a reversing valve. If it has a reversing valve, it's a heat pump, period. There are a few other telltale signs, but that's the obvious one. If you see a second metering device, but that's a little harder to see. But if it has an outdoor metering device, heat pump. A lot of times you can kind of get an idea by the stat, but not necessarily, because you can put a heat pump stat on an air conditioner or on a gas furnace. You just have to program it different. So don't go by that and say because the heat pump or the stat says this, that, or the other, that it has to be a heat pump. That's not necessarily the case. But in order to actually hook a system up, stat up to a system, it has to be made for a heat pump. So keep that in mind. So we'll get into that with the electrical part. But I'm going to stop this here and pick up later.